Welcome back, everybody. Our last section for Chapter 3 is solving nonlinear systems of equations. A nonlinear system means that one of our equations is not going to be a straight line. We're used to solving by substitution, elimination, graphing systems where both of our lines were straight. We reviewed that back in Chapter 1. Nonlinear systems means if not both, at least one is not going to be a straight line when we graph it. We're going to be strictly working with quadratic functions or parabolas for our nonlinear systems. So we could have a parabola with a straight line. We could have two parabolas. And these are just some variety of examples of what their intersections, if they have one, could look like. There are three types of solutions that we could have for our linear and nonlinear systems. No solution, where our two equations, the lines that we graph, just will not touch. Because remember, a solution to a system is the place where the lines are crossing. And those are always going to be given in ordered pair form. They could graph and have one solution. They could graph and have two solutions. We are going to skip the graphing part for today. That's what we're going to talk about in class on block day. We're going to go ahead and head all the way over to solving by substitution. So when we're solving for substitution, we're taking one equation and getting either x or y alone. We substitute that into the second equation for the variable that we solved for. Solve for the variable that's left. You might get to factor. Plug the solution or solutions into the first equation, and that'll give you the value or values of the second one. So we have our two equations here, for example, 2. We have equation 1, which is our nonlinear. We know that because of the x squared. And then our linear equation is the x plus y is equal to 4. So I'm going to solve the bottom equation for y. I'm going to subtract x over here to get y alone. And I have y is equal to 4 minus x. Oops. Sorry about that. So I'm going to take that and I'm going to plug my 4 minus x in for this y right here. So that's going to give me x squared plus x minus 4 minus x in for the y is equal to -1. I'm going to distribute the negative. X squared plus x minus 4 plus x is equal to -1. I'm going to combine these two like terms. Now they're on the same side, so we don't do opposite operations. So 1x plus 1x is 2x. And then, because I know I'm probably going to have to factor, and my equation has to be set equal to 0 in order to solve by factoring, I'm going to add the 1 over on the right to the -4, its like term on the left, which gives me a balance of -3. So now we're factoring. 1 times -3 is -3. The two factors of -3 that add to +2 are 3 and -1. So when I do my preferred factoring method, I get x, I'll go up there, plus 3 and x minus 1 is equal to 0. To solve, You set your two factors equal to 0, so x plus 3 is equal to 0, and x minus 1 is equal to 0. Subtract 3 to get x is equal to negative 3. Add 1 to get x is equal to positive 1. So that's the first part. We know that we have two x values, one at negative 3 and one at positive 1. But remember, our answers are ordered pairs, x and y. So before I'm finished, I have to take those two answers and plug them in for x. In either equation, it doesn't matter, to find y. So I'm actually going to plug it into that second equation that we already solved for y. So y is equal to 4 minus x is negative 3 first. 4 minus negative 3 gives me 7. So my first solution is negative 3, positive 7, where these two lines will cross. Then I have to plug in my x is 1. So y is equal to 4 minus 1, and 4 minus 1 is 3. So my second solution is 1, 3. These two are the solutions to my system. All right, my second one. I think again I'm going to go ahead and move my 2x in my linear equation over to the other side to get y alone. So I'm plugging 7 minus 2x in for that y. That gives me x squared plus 2x minus, please don't forget that subtraction, 7 minus 2x is equal to 5. And distribute my negative 1, x squared plus 2x minus 7 plus 2x is equal to 5. I'm going to combine these two like terms. Again, they're on the same side, so I don't have to do opposite operations, and they just add to 4. And then I'm going to subtract the 5 over to the 7 because we know in order to solve using factoring, our equation has to be equal to 0, which now it is. So 1 times negative 12 is negative 12. The factors of negative 12 that add to positive 4 are going to be positive 6 and negative 2. So whatever preferred method of factoring that you're using, you would get x plus 6 times x minus 2 is equal to 0. I'm going to go ahead and finish solving by taking each of those factors, set them equal to 0, and solve for x. On the left, we're subtracting 6, so x is equal to negative 6. On the right, we're adding 2, so x is equal to positive 2. But remember, that's only part of our answer. Those are my x values. I still need y values because in the end, these are ordered pairs. These are places where these two lines are going to cross. So I'm going to plug in those two values to this equation. We've already solved for y. I'm going to start with the negative 6. So 7 minus 2 times negative 6. That's 7 plus 12, which is 19. So one of our solutions is negative 6, 19. Then I'm going to plug in the 2. Y is equal to 7 minus 2 times 2. That's 7 minus 4, which is 3. So my second solution is 2, 3. And these are the solutions that I would put on my paper. This is where we're going to pause for tonight. Please remember, if you have a graphing calculator, to bring that with you tomorrow. So we'll talk about the graphing. And then tomorrow night, you'll be watching night 2. Thanks, everybody.